Is everybody done copying this down? Almost. I'll just, for the video, I'll just put the stuff that we had on there from before. So we had those, the factoring. Okay, so to factor without algetiles, what you're going to look for is you're going to look at the numbers and say, is there a greatest common factor between 2 and 4? Is there something I can divide both those numbers by? Yes. I can divide both 2 and 4 by 2. Then I look at my variables. Are there variables in common? First one has x cubed. The second one has x squared. Now x cubed means x times x times x. And x squared means x times x. So what do they have in common? They have two x's in common, and x squared in common. X times x. Then we set up our brackets and say, what would be left? 2x squared times what is 2x cubed? Just an x, right? And 2x squared times what would be 4x squared? We would need just a 2. So there's, you factor it. Now always, always, always when you factor it, right after, in your head, you're going to imagine multiplying this out and doing a quick check to see if it's the same. You don't have to write it out as a check, but you're going to see 2x squared times x, yes, 2x cubed. 2x squared times 2, yes, 4x squared. And then you're done. The nice thing about this method is then if the variables change and you don't have algetiles for an x cubed, you can still factor, or a y cubed in this case. When you have three things, you're going to need to find a common factor in all three. So when we look at the numbers here, -3, 3, and -6, is there something in common that divides all of them? 3. So, wow, computer is really slow today. There we go. Hopefully okay, let's, wow. Okay, that's working better. There's a 3 you could pull out. Before I put the bracket, let me just erase that bracket. Let's look at our variables. Is there a variable in common in all three of them? Y. And only one y, right? Because we have to look, it has to be in all three of them. So then when we look what's left, what would I have to multiply 3y by for the first one? Well, I'd still need a negative to make it -3. And I have a y cubed, so I need still y squared. For the second one, I would still need a y. The 3 is there, but I only have one y, so I'd need another y. And the last one, I would need a -2. Again, do a quick check. If you distributed that 3y, would you get what you had originally? Okay? Now, some people would say, well, you could pull out a 3. You could also pull out a -3, right? With negative signs, you can choose where you want them. This would be fine if you left it with a 3y in front. Okay? Sometimes we're going to find out it's more advantageous to have the -3y out in front. So if you took out a -3y instead of a 3y, can you see that instead of a -y squared, you'd have a positive y squared? Instead of a positive y, now I'd have a -y. And instead of a -2, I would now have a +2. Because now if I distributed this, it still comes out to exactly the same thing that I started with. So sometimes it'll be an advantage to take out the negative. Sometimes it'll be an advantage to leave the negative inside the bracket. And we're going to see that later on. But it's just nice to see that either of these would be correct when factoring. You have that choice with the negative. So now we're going to do a bunch. I'm going to give you guys a head start. And then we'll put the answers up and see how you did. Okay, how did you do? Did you see that in those three, you could pull out a 2? The only variables that are common in each of the three are B and C. What's left in the first one, you'd have to multiply by 3A. In the second one, you'd have to multiply by a 4D. And you pull out everything out of the last term, the negative 2BC, there would still have to be a 1 there. So when you distribute it, you can't put nothing there because then it would disappear completely. Again, do a quick check. When I multiply this out, do I get what I had to start with? Yes, I do. Here's another one to try. The biggest number that divides 8 and 12 is 6. And you're left with 3p cubed plus 2. Now you may find that sometimes, depending on how good your times table is and how good your factoring is, you know, when we did prime factorization, sometimes you could see it divided by 2, but you couldn't see the biggest number it could be divided by right away. If that happens, okay, if you say, I see a 2 right away, I don't see the 6, but I see a 2 right away, and you factor out a 2 and say, well, what's left? 9p cubed plus 6. This is partially factored. It's not factored completely. You would lose some marks on a quiz or a test if you left it like this because it's not factored completely. But if you do this to begin with, it's not wrong. We're just not finished yet. You'd have to check again. Is there anything else in common inside between a 9 and a 6? Oh, they both divide by 3. Now when I pull a 3 out, because there's already a 2 out in front, when that 3 comes out, it's going to be multiplied by that 2, and then you're going to get a 6. And pulling out a 3 will leave me with 3p cubed plus 2. And we do get the same final answer, just taking one more step. Obviously, it's nice if you see the 6 right away, because you can do the biggest step, and you get the right answer right away. But if you don't see the biggest one right away, you can start by pulling out smaller ones first, and then keep factoring, keep pulling out numbers until you're done. Pull out a 2 and an x, leaving you with x squared plus 2x plus 4. And remember that inside the brackets, none of those are like terms. Remember like terms from last year? Can't combine them. Can only combine like terms if you have x's with x's together or x squareds with x squared. The variables have to be the same with the same powers in order to combine them as like terms. All right, what number can you pull out? And any variables? M and n. That'll leave you with a 1 here at the beginning. And plus 2. And we need one more m and one more n. And it doesn't matter if you write nm or mn. Mathematically, they do alphabetical more often than not. So what I had here with the n squared, m squared should have been m squared, n squared alphabetically, but doesn't make a difference. And again, you multiply it out afterwards to see if when I distribute this, does it work out to be the same thing. right, the biggest number that divides all three of those is a 3. We have one S in common and one T in common in all of them. That will leave us with 5 minus 7ST plus 2S squared. And again, do a quick check. If I distribute this, do I get what I started with? And if you do, you know that those two are equal. Last example, then I'll give you some time to practice. You can check to see how you did. And then you can take some time. Right now we'll take about 10 minutes and then to work on this. That'll give you a good start. Maybe you might even finish this homework.